Hey everyone! Thank you for joining us for the next session of Model Mondays. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our host and presenters to answer. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our host for today. Bethany, thanks so much for joining.
Yeah, thank you. Thank you so much, Anna, for that sweet introduction. It's so nice to be here with you. This is the second Model Monday session of the year. I'm so happy. It's setting the tone for the year. And today is a fun episode because we have two guests. We have two tech spotlights. Not like the usual one person, but we have two people. We'll be talking about Responses API, and we'll also be talking about fine-tuning. Before I go into the stream, the first thing is everything you need to know about Model Mondays, anything you need to figure out about it will be on the link, aka.ms/-Model Mondays. That's where you'll go to find all the resources you need. And all this series will be running every other Monday until April. So you'll have various sessions, various people hosted on this channel. As I said, today we'll be having two guests. So we'll have Dave Voutila, who will be talking about fine-tuning, and then we'll have Gregory, who will be talking about Responses API. And before I go even into speakers for the day and what we'll be covering, I can see the chat is very active. So we have Niti in the chat, who will be our moderator. She's also the founder of this session. So I'm always happy to see her around. And I'm seeing we have a lot of people joining us we have someone from the US, we have someone from Netherlands. So thank you so much for joining us. And with that, I'll go directly to Guy. So Guy, welcome to the session.
Thank you very much, Bethany. It's great to be here.
It would be great if you first do an introduction and tell us about yourself, what you do, and then we'll dive now into the tech spotlight.
Yeah, absolutely. Thank you for having me on. I'm a long-time Model Mondays fan, so it's great to be on here. I'm a partner solution architect, and I work with our UK and Ireland partners. My focus is Microsoft Foundry, GitHub, and GitHub Copilot. And yeah, I help our partners to be successful building solutions for our customers with those tools.
Yeah, thank you. Thank you for the introduction. At least we have a similar time zone. So as we are well into the evening right now, thank you so much. And one thing about this session is, I think this is the first time we're doing a session on Responses API. Can you shed some light into what it is before you go into the demo? Like, what should even people care about what it is?
Yeah, so Responses API, I see it as a foundational API when you're building agents and applications that specifically are using OpenAI models and Azure OpenAI. It is an updated API that was launched by OpenAI last March. It simultaneously launched on OpenAI's platform and on Microsoft Foundry. And it's kind of an updated API which combines the simplicity of the chat completions API with the tool use capabilities that we had with the old assistance API, which, OpenAI have announced a retirement of that. We're also going to be retiring the assistance API this year. So now is a great time to think about moving on to Responses API or a framework that supports Responses API. It's an API which supports, reasoning by default. It supports multiple modalities by default. It's a really simple and elegant API, and it has a load of really convenient features that really help developers to build AI apps and agents faster than ever before. And it also works in an agentic loop as well. So rather than with chat completions, where you would send your request over, the request would get processed by the LLM, and then you'd get the output back. Responses API is designed to work with tools, multiple tools, so that you can actually send the request over. The request then gets dealt with perhaps with one tool. The output of that then gets fed into another tool, and then the output of that then gets summarized and sent back to the user. So it's a much more agentic approach, and I've been using it now really for the last 9 or 10 months, and I find it a really good API to build agents with. And the reality is that a lot of people will be using Responses API and perhaps aren't even aware of that, because there are frameworks like LangChain, like Agent Framework, Foundry Agent Service, which are actually using Responses API under the hood. So you may very well already be using Responses API and you're just not aware of it.
Okay, thank you so much for that description. My cat just decided to come sit in front of me, so no problem. Thank you so much for that description. And I feel like Responses API brings together everything into one. So it's unified and it's very simple to use. And you'll see that in your demo, right? How simple it is to get started and to use it. So let's head over for the demo.
Sure. So all right then. Now we're going to have a look at a Responses API Python SDK example. Again, starting at the Microsoft Learn Documentations page, we're going to scroll down to here to have a look at the API key example for Python. There's also a sample here for Entra ID authentication. But in this case, we're going to start off with this just basic input-output request. And I'm going to switch over to VS Code. And this is the code sample here where we're importing the OpenAI SDK, or importing the library into our code. We are then also importing the environment variables that we have stored in this .env file. I'm not going to show you my .env file, but you can actually customize this sample here with your own v1 endpoint, your model deployment name, and your OpenAI key. Once you've done that, let's run this. You'll see we can create our responses request. And in this case, we are specifying the model deployment name and the prompt. And then once the response is completed, we are able to output the response. And we're able to actually extract the text by using this method here. Really nice convenience feature, which prevents you from having to parse the JSON to extract that response text. So here we go. Here is the joke that it's generated. So really simple, 17 lines of code, really easy to get started. Now, to extend this slightly, we can also have a look at the message chaining feature. This is the ability for you to provide the previous response ID back to the model when you're providing the request, so that it knows the message history essentially for that conversation. And in this example, we've essentially done it so that it will loop around continually, providing the previous response ID each time. And then, so if we try this example out, we should be able to then have a message conversation that will go on indefinitely until you exit the program. So if I just say, hi, my name is Guy, and I like black coffee. It's going to probably come back with something, making some sort of observation about black coffee. Let's have a look and see what it does. Yeah, okay. Now, the nice thing is now if I ask it a question like, what is my name and what do I like to drink? Because it's referencing those previous messages, it's able to pull out that information from the chat history. Your name is Guy and you like black coffee. So again, able to provide context for long-running multi-turn conversations without you having to then implement a kind of conversation state function and track all of these conversation histories like you would with chat completions. All of these code samples are available in, obviously, Microsoft Learn. You can see there's a really comprehensive Microsoft Learn page here, including things like using remote MCP servers. We've also got a responses API GitHub repo, which is full of code samples that can be accessed through this easy to remember URL, aka.ms/responses API. Again, you can see we've got a whole host of code samples here, ranging from basic samples all the way through to the more complicated samples, so structured outputs, MCP. And the nice thing about this is, you can get up and running really quickly. There's an option here to click and open this repo in a GitHub Codespace. And here's one that I have made earlier. So this is all running in GitHub in a containerized environment. And if you want to try out these samples, all you need to do is just take the env.sample file, copy it to a .env file, and then customize the environment variables for your particular Foundry project. And then obviously if I run that example, you'll see that we'll get the response back. So really simple to do, and really easy to get started with this documentation and the samples that are contained in this repository.
Thank you so much for that demo. That's such a wonderful and short and direct to the point demo. So one of the questions is around, I've seen the question on LinkedIn around Microsoft Agent Framework and the relationship between Responses API, the different frameworks. So why exactly will someone use Responses API over Microsoft Agent Framework, or what's the relationship between all these frameworks and Responses API?
Yeah, that's a really great question. And, like I said before, the reality is if you're using one of these frameworks, whether it's something like Microsoft Agent Framework, LangChain, or the new Foundry Agent Service, there's a very good chance you're actually using Responses API under the hood anyway, because these frameworks, they're not re-implementing the API. They're essentially bringing in the responses client either from the Foundry SDK or directly from the OpenAI SDK. So, there's a very good chance that you're using those. Now, if you're running on something like the original agent framework, the V1 agent framework, then that does run on the Assistance API. And like I said before, we are retiring that this year at some point. So now is a really good time to think about migrating from the original version of Foundry Agent Service to the new version of Foundry Agent Service that we launched at Microsoft Ignite last year. And even there was, I saw the new GitHub Copilot SDK. I was playing with that today. That also leverages Responses API under the hood, and you can see that because the framework is open source. You can have a look at the code. So yeah, as you probably can imagine, lots of these frameworks are actually using Responses API under the hood. And you can see on this diagram here, if you're using the original chat completions, it's fine if you're just doing basic inference using one of the older models, like a non-reasoning model. And if that's all you're ever going to do with your application, then, it's fine. You can leave it on chat completions. Chat completions is so broadly deployed now that, I don't think that's going to be retired anytime soon. That's going to be around for a while. Assistance API, Assistance API came out with some great features. It came out with the ability to have threaded conversations, and it had some initial tools that were available. But Assistance API never really left preview, and for that reason, there aren't that many customers that are actually using it in production today. I guess the main exception of that really would be for anyone that's running on the original Foundry Agent service, where Assistance API is kind of underpinning that service. So, and that's the reason why I think now is a great time to have a think about migrating to either a Responses API or a newer agent framework. And you can see on that chart here that, Responses API, it's fully featured. It includes all the features that are in chat completions and Assistance API, and it handles things like the reasoning models. It handles multimodality so much better than chat completions. It has a really great advantage that with the reasoning models, not only do you have the ability to include a reasoning summary, but also when you're using the models in a multi-turn conversation, it actually passes the reasoning, the chain of thought through those turns behind the scenes. So really great functionality, and it's got these new features which everyone's starting to know and love now, like MCP support, image gen, and also things like computer use. And so all of the new innovation, all of the investment, both from OpenAI and from Microsoft, is really going into the responses API now.
Yeah, thank you. Thank you for that summary. We have some questions from the YouTube chat. So we have Ravi who's saying, for him, it's not a question, but he's saying reasoning summaries in responses API is one of the big ones for me, especially in regards to explainable AI. So I think that's like a kudos to the team. And then we have Lebo who's asking, to like to see more examples, like that joke demo looked too simple. Is it really that easy to get started, or is it just like a fluke?
Yeah. Yeah, it is. Look, there's probably about 20 examples. If you go to the GitHub repo that I shared on the video, which is just, it's the link at the bottom there, which is aka.ms/responses API. And yeah, it is really that simple. It's designed to be simple. And I think it's a really elegant and easy to use API. One simple example here is that, with chat completions, if you just flick back to the previous slide for 1 second, the way that you would extract the output text from a chat completions response in the previous model, you would have to kind of parse out the JSON in order to get that output text. Whereas if you can see at the bottom there where it says, print response.output_text, this is a really nice convenience feature that just lets you access the output text directly without having to, spend, longer than you perhaps should trying to parse out that JSON response. It's things like that really that make it such a great API.
Yeah, thank you. Lebo is saying, yeah, it's good. I'll give it a try. So looking forward to see what you'll do with the responses API. And then I feel like this is the last question. What's the future?
Sure.
Like, what do you expect to come soon with responses API?
Yeah, well, there will continue to be innovation with responses API, both in in Microsoft Foundry and elsewhere. But one really interesting thing, which I'll touch on, is the fact that we will be getting some additional new features. So Conversations API will be coming soon to Responses API in Microsoft Foundry, and also we'll have additional functionality like compaction available via Responses API as well. Conversations API you can think of as a similar feature to the threads that you would have in Assistance API, so that you could actually manage, a conversation state that way. At the moment, there is, the ability to do message chaining, which again, it makes it easy to have these kind of long running conversations without having to implement that message history like you would with chat completions. But the Conversations API will sort of bring it to the next level. You can use Conversations today in Foundry Agent Service, but we're actually bringing it to the underlying Responses API if you just want to use that as well. And then looking forward, last week it was really interesting to see OpenAI announce the Open Responses spec, which is an open source spec. It's multi-provider, it's vendor neutral, and it's designed to standardize the interface between LLMs and the applications that are running them in a similar kind of way that kind of chat completions became the de facto standard for the the original, perhaps version 1 AI applications. And so Open Responses has had a really big uptake from a lot of providers like Hugging Face and Ollama, LM Studio, who have been some of the launch partners. And really excited to share today, actually, that the Foundry local team have been experimenting with Open Responses to see whether they can implement a responses compatible API with their local Foundry solution. So, and really quite pleased to share that the team have actually come up with an experimental prototype just to showcase what that would look like, to be able to then deliver responses or open responses compatible interactions with those locally running SLMs. And actually, we have a video that we can share as well for that as well.
So a few months ago, OpenAI came out with the Responses API, which is their most advanced interface for generating model responses. About a week ago, they came public with it and opened up the spec. Open Responses was a quick community response to that to unify the spec for many model providers. And with Foundry Local, since we are a model provider, we wanted to make sure that that was something that we could do. So with quick iteration, we were able to jump on the project and get that working. We wrote an internal testing demo, which I'm going to run now. And we'll go through the process of basic text responses, streaming. You can see this model's not very smart. A system prompt that makes you talk like a pirate. A multi-turn conversation. Tool calling, which in the previous implementation didn't work that way. We don't yet support image input, so that's going to fail. We've got instruction parameters, and we even limit max output tokens. Now that's cool, but what do those look like when we go ahead and run these out of the actual open responses integration tests? Let's figure that out. So we have the basic text response working. We've got their streaming responses validated, their system prompt working, their tool calling working, and their multi-turn conversation working. Now, as mentioned earlier, because we don't yet support image input, we output this error, but that is to be expected. All this work was done in about a week, and I think that's really awesome how quick we're able to iterate now with AI.
Yeah, that's amazing. Like the launch is within a week, and we have a demo ready in Foundry Local. So we have one last set. This is like a set of questions from JDeep on LinkedIn. So I'll bunch a couple of them together. So one of them is, will Responses API replace chat completions and AI assistant? And then when should they migrate to Responses API? Are you muted?
Yeah, so to summarize, if you're on chat completions today and you're happy and you're never going to need any of the additional capabilities that Responses API brings, then there's no rush to change, right? You can stay on chat completions if you like. Of course, if you want to use the new models like GPT-5 family and you want to get the most out of those models, then really it's a good time to think about migrating. If you want to take advantage of features like MCP, computer use, then it unlocks a whole new range of features. Now, if you're on Assistance API, that's different. We are expecting to retire Assistance API and the V1 of Foundry Agent Service this year. So, now is the time to start looking at migrating, and the migration isn't particularly too difficult. And we have lots of partners, lots of folks who can help with the migration from those APIs. Also, we have the fantastic Foundry community. Shout out to the Discord. There's some great chats going on there around, and loads of people can chime in and help with questions about migrating from one API to the other. In terms of timing, certainly start to try out the new features within Responses API now and start to think about, how you can leverage some of those new features. And of course, to get the most out of the platform, have a look at Microsoft Agent Framework and Foundry Agent Service, which really provide a whole load of additional tools, enterprise observability, and things like authentication that really kind of help accelerate that journey to building agents.
Yeah. Thank you so much. So you have two more questions. So the other question is there a benchmark that compares the latency between Responses API and other APIs? And then how does it handle long conversations without hitting the context window limits.
Yeah, I've not really noticed any major difference in terms of the API latency, because at the end of the day, it's mainly down to the models. One thing I will say is that if you're using models like GPT-5, which can do this kind of more of an agentic reasoning approach, it can take a longer time to get that response back. In which case, Responses API supports background mode, so you can actually send your request asynchronously and come back to get that response, which might be required if you're using a reasoning model like GPT-5 Pro, or if you're simply sending a quite complicated request, which might take maybe even a few minutes to come back. So that background mode is is really worth checking out, and that's part of the Responses API spec as well.
Yeah, thank you. Thank you so much for the answers. I'm sure people are eager to try out Responses API because of how simple and straightforward it is. Thank you also for sharing what's coming up, especially the fact that Open Responses is already in preview in Foundry Local. So that's really, really nice. Thank you so much. And I think we'll move into the next speaker. So we have Dave, who will be talking about fine-tuning. Welcome, Dave.
Hi.
Hi, you can give us a short introduction of who you are, what you do at Microsoft. Yeah.
Sure. Yeah, I'm Dave Voutila. I'm a principal product manager within Core AI. What that really means is I work on Microsoft Foundry, specifically model customization. So our team is focused on pretty much all things fine-tuning or fine-tuning adjacent.
Yeah, thank you. Brief and to the point. Thank you so much. So we'll go into your video. I know you've already, in the video, you already explained what fine-tuning is and everything else. But before we go on to the video, if you have any question around fine-tuning, you can share with us on the chat, and then we'll be able to respond to them afterwards. Okay, over to the video. Anna, thank you.
Hello, everybody. I'm Dave Voutila. I'm here to talk to you about fine-tuning and distillation. I'm a principal product manager with the Microsoft Foundry team and work on model customization. So let's first define fine-tuning. So fine-tuning is all about adapting a model's behavior. So we offer a variety of fine-tuning services within Foundry, supervised fine-tuning and reinforcement fine-tuning primarily across a handful of models. The overall goal of fine-tuning a model is typically to tweak or tune the behavior to fit a use case. So a base model might not be performing well in a particular domain, might not be eliciting this correct style or tone in how it engages with your users through an agent, or it just is not working well with the tools that you have given it. Fine-tuning can improve all of these aspects. What fine-tuning is not is about grounding. So typically you use fine-tuning in conjunction with things like RAG in order to bring in ground truth and improve the performance of the model with that ground truth. What is distillation? So distillation is a form of fine-tuning where typically you're taking the characteristics of a larger model that's maybe capable of performing the task already and using that to improve the performance of a smaller model at that task. So in this case, we're going to go through an example of distillation today, but the general idea is for one type of distillation, you might just take the responses from a larger model, use those as the training data to show the smaller model, this is what I want you to do in these situations. Why would you want to do distillation or even fine-tuning in general? So typically there's kind of like two sides to this. One is cost optimization. If you can fine-tune a model, especially through distillation, you can typically shift to using a smaller model in your use case. Smaller models come with less cost, whether it's fewer GPUs needed or just a lower price per token. You can also improve accuracy and quality, even if you're using a smaller model. So distilling out the kind of the features and characteristics of a larger, more capable model into the smaller model can improve things like tool use, and also just do a better job at adapting to tone or style or particular natural language-like characteristics. In this case, we're going to show this tone adaptation concept, and we're going to do it through distilling sarcasm. Nice, simple example everyone should be able to understand. Let's say we have a prompt. Clippy is a factual chatbot that is also sarcastic. We're not going to do any prompt engineering here. We're just going to show how using distillation, we can improve the performance of a small model in being sarcastic, yet also still factually correct when answering questions. The methodology we're going to use today is pretty straightforward. We're going to generate a variety of sample questions. We're going to then use those samples to find and grade a variety of base model candidates to find the right teacher that we're going to use for distillation. We're going to use that teacher to generate the training data. And then once we train the small model candidates, we're going to post-train evaluate them to see if we've improved. All of the materials here are available in a notebook within our demo repo. You can either use the QR code, or if you go into GitHub's, the Microsoft-Foundry GitHub org, I think it's an org, there's a fine-tuning project in there, has all the demo materials that we're going to show today. So that first step that we mentioned, it's all about finding the teacher. So what we need to do is generate some sample data, define what's called a grader, and we're going to use those to identify who our teacher is. So let's say we generated some data. You could use, Copilot for this. You could write some scripts, or maybe you just have enough data already. The general idea here is that you don't need anything like full chat completions. We just need some question answer pairs in our case, because we're going to have a use case where a user just asks the chatbot a question, and we need to have some ground truth to be able to understand, was the answer from the chatbot accurate? So these are just straightforward questions like, what is the capital city of Japan? Now we need a grader, or something to basically determine the response quality from the model. We can use another model for this, and we're going to be using O3 Mini in this particular demo. This is what's called a score model grader. So you basically prompt this other model to say, hey, I'm going to give you some question and answer pairs. These were generated by a different model. I need you to say, is this response sarcastic? And then here's the ground truth. Is the response accurate as well? So this other model is going to basically be the arbiter of what's sarcastic or not. So you do want to kind of prompt engineer the grader a bit. And then it's going to come up with a final score. So using the grader, we're able to then take any question and answer pair. So let's say we have the question of who composed the 4 seasons. We have our model that we're thinking will be a good Clippy model, generated something like just some obscure violinist named Vivaldi. Ever heard of him? We can show the grader, this is the result that we want it to score, and then it's going to give us back some reasoning around, okay, in this case, I scored it an 8 for these reasons. Put it all together, you can run an autonomous eval within Microsoft Foundry. So we can parameterize this across a variety of models to find our teacher very quickly. In this case, I used everything from Kimi K2 Thinking down to Ministral 3B. So just looking at the results in Foundry, in the UI, we can see that Kimi K2 Thinking actually, in this case, did the best. GPT-4.1 was okay. It generated the most sarcastic responses based on our grader. The ones who did the least actually were the smallest models, GPT-4.1 Nano and Ministral 3B. They both struggled to generate passing scores. And when you drill into the data itself, in this case in the notebook, I show you how to pull down the data and do a histogram plot. You can see that Ministral 3B, GPT-4.1 Nano, not only did they have the most kind of failing scores, but they also scored the lowest on the scale. So on a scale from 1 to 10, they got a lot of 1s or 2s. So what we want to do now is say, take Kimi K2 Thinking, and we're going to use that as our teacher, and that teacher is going to improve GPT-4.1 Nano in Ministral 3B. So how do we do that? We've already basically done half of it already. The teacher was already shown a bunch of prompts and generated a bunch of responses. So what we can do is now filter using the grader scores to generate our training data. So you can do this directly using the eval service. You can just basically go through the results and say, okay, let's see the ones that had the highest scores. So if we filter everything above a 6, let's say, we actually have 282 excellent responses from Kimi K2 Thinking. So I show you how to do this all programmatically in the notebook. You can basically have it be completely autonomous where you didn't have to manually choose the model. But this is a good way to kind of build that training data very quickly, just generally from your baselining. So if we take those 282 responses, create some supervised fine-tuning training set with it, we can then go train 4.1 Nano and Ministral 3B. So at some point in time later, you can look at our plots directly in the Foundry UI. In the interest of time, I skipped obviously doing the training live, but here we can see that 4.1 Nano is actually improving over the different steps of the training process, and the token accuracy is increasing. So loss is going down, that's good. Token accuracy is going up, that's good as well. Now within Foundry, we want to deploy these model candidates so we can evaluate them. after the fact. So in this particular demo, there's Mistral 3B and GPT-4.1 Nano that were trained. Depending on the model, you might have different options for deployment. We have a developer tier for deploying some of the OpenAI models, which has no hosting fee, so it's great for doing some model candidate validation. And for other models like Mistral 3B, we have global standard, which is pretty affordable as well, with developer tier coming soon. So after you deploy the models, you can use Foundry evals again to do the model candidate validation. So we're going to do the same thing we did before when baselining. We're going to basically take all these models, in this case our model candidates, and we'll also include the teachers and the base model kind of counterparts for a baseline kind of comparison. And because in the beginning we did that, if you remember, we took those question answer pairs and we kind of split it up. We held back some data that the models never saw in training. So this is going to be a nice fair validation of model performance. We're going to reuse that same grader that we had before. So we have all the pieces here. And now we're going to compare the models. We're going to do it at scale. So while you could go into Foundry in the Playground UI nowadays and compare two models side by side, so here we have the 4.1 Nano fine-tuned and Kimi K2 thinking being given the same prompt at the same time. You know, this is one way to do it, but we want to do this autonomously. So you can run another eval. Here I'm showing you some rendering in the notebook of the results just to kind of condense it all into one slide. But we can see that 4.1 Nano and Mistral 3B, the distilled versions, it's kind of cut off. It says -DI, which is short for distilled, perform much better than their base model counterparts, which kind of still scored at the bottom. Interestingly, like 4.1 Nano did really well. Well, from an improvement perspective, it's now kind of on par with Kimi K2 thinking for this particular use case, which is awesome because we went from a reasoning model, shifted gears into a chat model, which is going to save a lot of money in this particular use case. But for Mistral 3B, we see a good uplift, just not as much. And if we look at the actual histogram again, we can still see that it's got a lot of ones, but we did move the needle and we did get some higher scores. So this is an area where if we wanted to really focus on the smallest model possible, there's still a bit of a gap between 4.1 Nano and Mistral 3B, but we might want to go back and tweak some hyperparameters, for instance. But it's a nice jump. We went from like 25% up to 55%, I think, in terms of passing scores. So I know this is very fast, but definitely take a look at the demo materials. It shows you top to bottom how to do this. No smoke and mirrors. And looking forward to any questions. Thanks.
Demo Dave, that was incredible. Like, you took us from what fine-tuning is all the way till evaluations and understanding the different parts of fine-tuning, like what you need to do. And the good thing is next week we'll have a session on data, synthetic data generation. So watch the space. In terms of what you've just presented, there's a lot of people who are complaining about the volume of the video. So can you do like a quick summary of what you presented, like a 2-minute summary?
Yeah, not a problem. So what I took everyone through in the video is effectively fine-tuning from, beginning to end. So the problem we were trying to address with fine-tuning specifically was tone adaptation. So teaching a small model how to adapt to a tone that we want it to have. And the way we did that was generating training data from a more capable teacher model. So we found a model, in this case, it was Kimi K2 thinking, that demonstrated the ability to kind of solve the problem for us, the business problem in this case of, here's the tone we want you to elicit when you respond to a user. We distilled the capabilities of that Kimi K2 model by taking a bunch of generated responses to some inputs, some prompts, and then formed our training data from that. So then we use supervised fine-tuning to train both 4.1 Nano, GPT-4.1 Nano, that is, the OpenAI model, as well as Mistral's Mistral 3B. The naming always trips me up when I say it or type it. So the attempt was to basically take the two smallest models that we demonstrated showed very poor scores in the baseline eval and try to improve them using distillation. In the end, 4.1 Nano improved quite considerably. It went from effectively worst to almost first. It can kind of vary between runs, but it improved to be effectively on par with the teacher model. Now, that doesn't mean that we made 4.1 Nano magically as capable as a reasoning model like Kimi K2 thinking, but in this particular domain of adapting to tone, it's able to now perform effectively on par. So this allows us to shift gears, whether we're trying to do cost optimization or performance optimization or both, where we can move from a reasoning model like Kimi K2 thinking that might have kind of slower response times because it's a reasoning model, number one, and also typically higher cost per token, to something like a GPT-4.1 Nano or Mistral 3B, where cost per token is a lot lower, latency is a lot lower, throughput's usually a lot higher in any of the chat models.
Yeah,
And
thank you.
Everything's in that notebook. So, if that was also too fast, I don't know, I get to go back and rewatch the video in the future, but the notebook takes you through it from beginning to end. It doesn't handle the data synthesis part, but it handles basically all of the baseline evals, the teacher selection, student selection, how to submit the training jobs, and then do post-training eval, all within Foundry.
Yeah, that was great. Like, that's such a good summary. And there's a comment from Lee saying it's great that you can now fine-tune with different models in Foundry. So one major question that comes up is in terms of licensing. So like when you're fine-tuning, let's say Kimi to Distilling to GPT Nano or Kimi to Mistral. So how does it work in terms of generally, which terms is that the right word? Like, what are the guidance of that? Is it OpenAI guidance? Is it like Mistral guidance? Like, what's the baseline when you look at it that way?
Yeah, so there's the short answer and the long answer. The short answer is I am not a lawyer and I'm not giving legal advice. I'm a product manager representing Microsoft. Short answer is if you're doing this all within Foundry, you never have to worry about that. You're covered by effectively product terms and licensing. There sometimes for some models, if you have kind of supplemental agreements through like marketplace offers, there might be third-party terms of service. But if you're doing everything within Foundry, like I'm doing in this demo, you can be distilling from a GPT 5.2 model to a GPT 4.1 Nano and stay compliant within any of the model provider terms. The longer answer is it definitely is a per provider type of thing. So it's a messy space where we talk about open weight models, but every model typically comes with its own licensing terms and all that minutia. I mean, that's one of the reasons for using a service like Foundry and Foundry Direct models, because effectively, if you're an enterprise, you only have to worry about your agreement with Microsoft and the Microsoft product terms, not each individual provider.
Makes sense. So I have a question by Kalyana. So she's asking, she had two questions. She's asking, can we fine-tune local models? That was the first question. I think this is around, you have your own local model, are you able to fine-tune it? I'm not sure. Okay, you can answer that. And then the next question is, can we estimate the cost before fine-tuning?
Yes. So two good questions. For fine-tuning locally, I'm not part of the Foundry local team, but I know you can use Foundry local primarily for inference. A lot of people use open source fine-tuning services or tools from things like Hugging Face or Unsloth. So if you do have, if you mean local in the sense of I'm doing it on my own hardware, like a laptop, those are usually where you'd want to look. And what you want to look for specifically, typically, is parameter efficient fine-tuning. You'll see it either abbreviated PEFT, or people will talk about the outcome of it, which is called LoRa, low rank adaptation. I can't remember the exact acronym meaning, but the general idea is that type of fine-tuning scales down really well, especially for local use cases with smaller models. Just like Mistral 3B, for instance, is a smaller model. And what LoRa does is effectively change a subset of the weights. So like, that's sort of how to look at it. Using some linear algebra, it basically lets you do less work to have an impact on a larger model. So the net result is shorter training times, maybe less GPU needs for training. And then from an inference perspective, there's a lot of cool things that LoRa can do. For the second question, which was about understanding cost of training. So training costs, you can look at a couple different ways. So if you're doing it locally, it's all about typically going to be, getting access to a GPU or GPUs, multiple of them, and for how long? Because usually if you're getting access to direct, individual GPUs and you don't physically own them yourself, usually paying per hour. With a service like Foundry, with our fine-tuning services, they're all designed to be fine-tuning as a service. And for all of the supervised fine-tuning we offer, like I demonstrate in the demo, it's all billed per token. So you can get a very good cost estimate for supervised fine-tuning in Foundry if you know the training data size and then the hyperparameters you're using. It's usually quite predictable. So if you have a training data set that has 1 million tokens in it and generates another million, that's effectively like 2 million training tokens. And then all of the models have individual per model training token costs, typically per million. So you can do a very good job estimating. Supervised fine-tuning jobs in general, I would say with data sets like in the demo here, are usually measured in dollars, single dollars or tens of dollars typically. You can get some larger jobs if you're using a larger model like a GPT-4.1 or 4.0, and you're running a lot of training data with a lot of epochs. You can scale that up into hundreds of dollars or low thousands potentially. So fine-tuning, you can really kind of fine-tune your costs as well. I would say if you're getting into fine-tuning and you've never done it before, what you want to look at in Foundry is choosing a small but adaptable model like 4.1 Nano. It's pretty good at supervised fine-tuning. It's also pretty affordable. We also now offer what's called our developer training offer. I'm blanking on vocabulary and synonyms today. What developer training does is give you effectively a 50% discount per token in exchange for us being able to schedule your job to run at some point in the future. So hopefully that helped answer the question.
Yeah, that really helped with a lot of questions. So we have one last question. It's been a very interesting question in the chat. And I think what's new, you already covered in the question around what you can do. So I'll want you to answer 2 things. So number 1 is a question around distillation and fine-tuning from Ravi. So Ravi is asking, so the process for distilling are similar to fine-tuning, or what's the difference between distillation and fine-tuning? And then you can summarize with what's new, what you just recently announced, other than the fact that you can now train more models. What else is new with fine-tuning in Foundry?
So distilling and fine-tuning and how they're related. Fine-tuning, you can do distillation by doing forms of fine-tuning. So distillation, and I know about last year when I appeared on a Model Mondays, I went a little bit more in depth into the different types of distillation. Distillation is really kind of like a family of techniques for adapting models, specifically deriving capabilities from another model that's usually larger than it. Distillation is pretty common, and it's commonly used for producing the smaller derivative models that you see. So like GPT-4.1 Nano is actually derived and distilled from like GPT-4.1, for example. And so distillation, you're typically reducing the size and complexity of the model weights while trying to keep and persist some characteristics from that larger model, or you're trying to impart those characteristics into a small model. Fine-tuning is how you might do that. You might go about doing distillation. So it's kind of like an application of training to achieve distillation. So different types of fine-tuning include supervised fine-tuning, which we kind of go through in the demo, where you're basically showing a model inputs and outputs and saying, I want you to behave like this in these situations. And it's kind of like beating it into adapting to fit that pattern. And then there's also other things more reinforcement based. So reinforcement learning, there's a lot of different types. We offer reinforcement fine tuning, where you're showing the model an input, and then you're scoring it based on its output and trying to adapt its chain of thought. You can use different types of fine tuning for achieving distillation. There's also some other cool stuff you can do to achieve distillation that's actually neither supervised fine tuning nor reinforcement learning. It's a lot lower level, and it's something we could have an entire session talking about. As for kind of new stuff coming up in Foundry, the slides mentioned some of the recent things we announced, mostly at Ignite in last November, a couple months ago now. Minstrel 3B, which I used in the demo, as well as Quen 3 32B, which is a small reasoning model. We've got some more models in the pipeline coming out in the coming months as well, especially as we lead up to build. So those two models are available for supervised fine-tuning today. I think the other big announcements were the developer training, which I mentioned a couple minutes ago, where at least for the OpenAI models currently, it's sort of like our global training service we introduced last year, but while being global, it's also at half the price. So you let us run on effectively spot capacity, and we give you a 50% discount, which everybody likes to see. You get the same end result. It's the same training code, same training service. It's just in exchange for a little bit of latency in running your job, we give you a big discount. The other big thing is to kind of tease synthetic data generation, which will be featured in another upcoming Model Monday event. So I don't want to go into all the details of that, but as part of Foundry, there's now a dedicated synthetic data generation service. Usually one of the challenges to doing fine tuning is getting the training data to do so. A lot of days, and especially if you kind of keep up to date on like new model releases from like the different frontier labs, even they are starting to run out of enough training data to improve current kind of state-of-the-art models, and they're switching to, or have already switched to, synthetic data. So generating more examples from a small subset. So starting with a little seed, and basically letting that grow into a larger data set that you can then have enough chances to improve the model or change its behavior through fine-tuning. So I know William will be on, and he's also a member of my team, and we'll be taking through that. So I won't spoil the fun.
Yeah, thank you. Thank you so much, Dave. And the good thing is we'll have our AMA this coming Friday. So watch out for that. I'll make an announcement at the end. But thank you so much, Dave, for this segment. The last section is our customer story. So our customer story is from Relativity, and they're talking about how they're using AI in their law firm, in their legal day-to-day activities. So let me hand it over to Anne for the video.
So we have a great partnership with Relativity, and amazing story, because one of the hardest problem is working with lawyers and legal, because we have mountains and mountains of documents there, and how do you sift intelligence out of this? To talk about this, I'm going to invite John Banter, VP of Product of Relativity, who's been here from Chicago. So John, please welcome.
Thanks, Anand. Good morning, everyone. It's a pleasure to be here with you today. For those of you who are not familiar with Relativity, we're a legal tech platform company rooted in e-discovery. And that's the process of searching and analyzing vast amounts of electronic data during a legal proceeding or an investigation. And we power some of the world's most critical legal, compliance, and investigative work. And our platform must preserve trust in global matters while handling petabytes of highly sensitive data. Deployed across 19 Azure regions, our flagship SaaS product, Relativity One, supports hundreds of thousands of users across the globe. And here are some examples of the types of projects for which our customers rely on Relativity. They're tackling some of the most challenging matters, from litigation to investigations, regulatory requests, contract reviews, public and private sector information requests, and even cyber data breach response, and much, much more. Now, as I was preparing for this trip to San Francisco, I found myself thinking about the gold rush that occurred here in the 1800s, and how those early miners faced a challenge not unlike what our e-discovery practitioners face today. And they sifted through tons of rock and sediment in search of just a few ounces of gold. And I love this picture as it shows that their success depended on their tools. They had shovels, pans, and sluices to separate the precious from the ordinary. And fast forward to today, our users face digital mountains instead. We've got terabytes of email, chat logs, documents, spreadsheets, and even body cam videos. And just like the miners, they're searching for the nuggets of truth hidden in all of that data so that they can take action on what matters. Now, our modern day sluice box is generative AI. At Relativity, we use an ensemble of specialized models, each built for a specific purpose, working together to accelerate insight, filter out the noise, and surface the value most effectively and much more effectively than ever before. Now, all of our AI products sit atop this foundation enabled by Azure, enabling Relativity to power not just litigation, but the entire legal data intelligence landscape in an end-to-end platform. One of our innovations this year is our new prompt Kickstart model, which is built to amplify and accelerate the power of Relativity's AIR for review by getting users into the document review process faster. It takes the artifacts that they already have, like a disclosure order, and automatically generates the right prompt criteria for the downstream processes. And let's take a quick look at that process in action. So this is a quick demo of AIR for review with an investigation involving a hypothetical company. Let's call them Big Thorium. And imagine you just received an urgent request to investigate a claim involving potential bribery. The first step is getting past a common challenge in generative AI workflows, which is drafting that right starting prompt. And for this, we developed Prompt Kickstart, where all you have to do is upload case background documents and AIR will take care of the rest. Drafting an overview of the matter, identifying key people and organizations involved, and any important terms. From here, you can further refine the prompt as needed. In this case, let's say the claim suggested a very expensive watch was involved, so let's add that detail to the overview. And many of our customers are using this process to create prompts in a matter of minutes, literally. And this is making it easier for a single lawyer, even one that's completely new to Relativity, to get up and running, saving hours in the process. Now, with the prompt ready to go, let's kick off AIR for review, powered by our models running in Azure. AIR takes that input and applies it to a sample set of documents to provide a preview of the initial result set, and it gives the user an opportunity to make any refinements as needed. From this initial result set, AIR shows predicted relevance for each document and provides a summary analysis along this top header bar. And additionally, it provides clear explanations for its reasoning, giving you much greater confidence in the results with transparent rationale coming from the documents. And of course, you can dig into the documents. You can drill into any of the documents to view a basic summary and description of what was found to more immediately understand and act on AIR's analysis. Now, there's so much to show in such little time. This is just a very high-level overview, but our users are seeing amazing results, higher accuracy, faster turnaround, and the peace of mind that comes from operating securely in Azure. And to showcase this, I want to show a quick clip where some of our customers speak to what the impact is of using these tools in their day-to-day lives.
Or at least for our Chief Security Office and our privacy and compliance teams, being in Azure was something that was easy for them to digest. We're also within Azure, so they're understanding the platform, the security around those platforms. For our legal teams, in terms of being able to gain trust within the tool and product, I think was just being able to see the results. Being able to not have something be a black box as to why a document is responsive or non-responsive has been allowing them to be able to gain confidence in the results of the data sets and that their prompts are actually generating what it is that they're looking for within the collections.
The machine doesn't get tired, it doesn't get cranky, it doesn't have sick days, it doesn't get confused, and it gives you this insight on every document, which is amazing.
living, right? Thank you so much. That demo was so interesting around how they're using AI to just simplify their work. And that's it for our session today. Next thing on our agenda is the Foundry Friday AMA. So if you're not on Discord, this is the right moment to join. We'll have an AMA this Friday with Dave and Alicia, both from the fine-tuning team. So if you have any questions and if any of your questions weren't answered, that is the place to be. And then next week, as Dave gave us insights on, we'll be having a session on synthetic data generation. So see you there. Don't miss it. It will be such a great session. And there's something interesting that may happen next week. So watch out for that session. Thank you so much, and have a lovely rest of your day. For those in the US time zone, and then for us in the EMEA time zone, have a good rest of your evening. Thank you so much, and bye.
Thank you all for joining, and thanks again to our speakers. This session is part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.